Okay, so the last topic we covered in class was the budgeting, or how to budget a project. Now we're going to transition to scheduling the project. And this is just the first part of this topic. We're going to have a couple of lectures on this subject. But we're going to focus today on two things. And this is part of your fifth objective for this class: create and analyze network diagrams to identify opportunities for reducing the project lead times. So these are the two things that we're going to focus today. We're going to learn how to create network diagrams for scheduling a project, and also how to find a critical path. I'm going to explain what the critical path is in a second. So at the end of this lecture, the students should be able to develop network diagrams, determine the critical path of projects, determine slacks of tasks under deterministic and stochastic conditions. Anyone knows what's the difference between those two? What is the difference between deterministic and stochastic? Any ideas?
At least I've got it. It looks like the mean average.
You're in the right track? Yes. So especially in this industrial engineering field, you will hear these two words a lot: deterministic and stochastic. And you need to know what's the difference between those. So when you look at deterministic parameters, for instance, you're saying that you know with 100% certainty the value of a parameter. So let's say you're talking about the demand. So you're saying the demand for next week is going to be 100, and that's not going to change. That's a deterministic parameter. But when you talk about stochastic conditions, you're saying it could be 100, it could be 200, 150. So you don't know with certainty what the value of that demand is going to be next week. So you're going to have some uncertainty involved in the parameter, and that's what makes the parameter stochastic. And that's when the expectation comes into play, because you can compute the expectation based on the chances of having 200, having 150, or having a 100 demand. Is that clear? So we're going to look first at the deterministic type of problem, and then we're going to transition to stochastic and see how uncertainty affects the schedule. So as an introduction, let's talk about what is a schedule. So when we talk about the budget, we saw that the budget is a different way to present the project plan. And that's the same case for the schedule. The project schedule is simply the project plan in a different format. It's also a convenient form for monitoring and controlling project activities. And these different format can be prepared on different ways. So the schedule itself can be prepared in several formats. In this class, we're going to talk about two different ways: the Pert diagrams and the CPM diagrams. But there are multiple ways in which you can prepare this schedule plan. And that's what we're going to do on the next slide, is basically define or explain what is a Pert and what is a CPM network. I think I'm getting ahead here. Yes. So in this chapter, we describe the most common format. Again, we talk about Gantt charts already. Those are the ones that you see on Microsoft Project. And we're going to talk about Pert and CPM networks. And how to convert the project plan or the work breakdown structure into these formats. We also note some of the strengths and weaknesses of different displays. So these displays will have both of them will have their advantages and their disadvantages, so we're going to talk about those also in class. So Pert and CPM networks. These diagrams were developed in the late 1950s, and their stands for Program Evaluation and Review Technique, that's Pert, and the Critical Path Method, that's CPM. They were independently developed. Pert, or PERT, was developed by the U.S. Navy, Booz Allen Hamilton, a business consulting firm, and Lockheed Aircraft. And CPM was developed by DuPont de Nemours Incorporated. So these companies are still alive, you can say. They're big companies, and they were basically looking at ways to improve their schedules, and they come up with these strategies that have become like the standards for doing these things. So both methods employ networks. Any ideas of what the network is? Have you seen a network? Can you identify a network? What would you see in a network? There's two major things that you need to identify in a network. What's that?
Process steps, operation steps.
I'm talking about the actual structure of the network. So you're going to have nodes and arcs. And those nodes are going to be connecting those arcs are going to be connecting those nodes. And you're going to have a path from one node to another. So that's essentially what defines a network. You're going to have a start and a finish, and you're going to have different tracks or paths to get from one point to the other. So both methods employ network to schedule and display task activities sequences. Both methods identify a critical path of tasks that could not be delayed without delaying the project. And we're going to go back to this definition later today, but this is very important. Once you create your network, you identify the task, you find the paths, the different paths for each task, and from finish to completion, from beginning to end, then you need to identify what is the critical path, which is essentially what we just said here. Critical path of tasks that cannot be delayed without delaying the project. Both methods identify activities with slack or float that could be delayed. So again, you're going to have multiple paths. Some of them will give you that extra time that you can use to change the activities, start and also finish times. But there are going to be paths in which you cannot do that, and that's your critical path. So this is without exceeding, or let's say extending, the time required to complete the project. We're going to use both names because users in real world are used to use either. So we're going to refer to them using these two names. So before we go to, is there any questions so far? So before we go into the actual networks, let's define some of the things that are important. So first of all, an activity is a task or task required by the project. So remember, when you define these work breakdown structures, you come up with level 1 task, level 2 task. Those are the activities that you're going to be taking into account for your schedule. An event is an identifiable state resulting from the completion of one or more activities. Okay, so if you think about, I don't know if you have taken this class in which you use Arena or Simio. In this class, you talk about discrete event simulation. That basically helps you to understand what is an event. So in discrete event simulation, you would change the time of your simulation once an event is completed. So an event is an identifiable state, something that you can say, okay, I'm processing this part. It's going to take me 30 minutes. So the machine is going to be busy 30 minutes, and after that, the machine is going to be idle. So busy and idle will be those two states, those identifiable states. Then we have milestones. So these are identifiable and not noteworthy events making significant progress on the project. So these are more high-level type of events that basically you can say, okay, I'm building this house, so the foundation is a milestone, the walls is another milestone, the roof is going to be another milestone, and so on. The next one is the network. A diagram of nodes connected by directional arcs that define the project and relationship between activities. So again, you're going to have nodes and arcs. Those are going to be connected, and that's going to provide you with some tracks that you're going to find, you're going to use to find your critical path. And a path is a series of connected activities between any two events in the network. So again, a critical path is a set of activities on a path from the project starts event to its finish event that, if delayed, will delay the completion date of the project. And the critical time is the time required to complete all the activities on the critical path. So you're going to identify the critical path, and then you're also going to identify the completion time of that critical path, which is the critical time. There are two ways in which you can build a network or display a project network. The first one is the activities on arrows, AOA network, which is this one. And in this way, we have activities that are shown as arrows, and events are shown as nodes. So arrows and nodes. The other type is the activities on nodes, AON, network. And in here we have the task is shown as a node, and the technological relationship is shown by the arrows. Usually this one, wait. This one is usually associated with CPM. And the AOA is usually associated with Pert. Okay, so two different type of ways to create your network, the AON and the AOA. And we're going to look at the difference with an example in a second. But before we build a network, there's two rules. Rule number one, after someone finishes an activity or reaches an event, he or she can proceed to the next activity as indicated by the arrows. So if you are coming to a node, the node is going to have a couple of arrows coming out of the node. Then those are the only paths that you can take, the ones that are defined by those arrows. Rule number two, to be able to start an activity or reach an event, someone must complete all the activities and reach all events from which arrows entering the activity or event emanate. So saying is, if you have a node, let me use a, so let's say we have this. This is node number 1, 2, 3. So in order for you to move from here to one of these two nodes, you need to make sure that these two activities are completed. Okay, so let's build a network. We're going to start with the AON. Again, AON network. Tasks are shown as a node, and the relationships are shown by the arrows. So we have here a list of activities or tasks. So this is information we're going to have. A, B, C, D, these are my tasks. And we also have the information about the predecessors. So this information is telling us how these tasks are connected. So we're going to start by just creating a start node. Maybe I should make that one bigger. Let's see. Start. And for the first two activities, there's nothing tying them. So these are my first two activities. So they're gonna start at the same time, and they're gonna come from here, from the start. So we're gonna have two arcs.
So, yeah, activity, the tasks are shown in the but you related tasks.
Yes, but the tasks are nodes, right? So we're going to make two nodes here, A and B. Okay, so those are the first two activities. You can actually start your network without having this start. This is just for representation purposes to let you know that this is the beginning of the network. But you don't need this first node. Okay, so that's the first part. Now we know that C has A as a predecessor, so you're gonna have C connected to A, and D is gonna be connected to B. So that's what we're gonna do on the next slide. So this is stage number 2. So we're gonna have the start node. This is A. This is B. These two are connected. Then we know that C is coming from A, and we have D and E. Yes, they're both connected to B. So I guess I'm going to continue from this one. This is not cooperating. Yes. Let's go back here. So from here we know, so we have A, B, C, and D already. Here, 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 and here. Now let's look at E. E. Oh, yes, we have that one too. So we only have two nodes. F. F is connected to C and D. So basically, you're going to draw a node here, and you're going to connect that node to these two. So F here, here, and then G as E. So this will be connected here. And finally, we have finish. And you just created your first network. Okay, so we have 7 nodes, and we have the relationship between those tasks, and we can draw a network based on that. Any questions? Okay, so now we're going to do the same example, but using the AO8 network. So in this case, our activities or tasks are represented by the arcs. And I believe this one, the AON, is easier to represent. The other one can be a little bit confusing. So let's try. So let's draw the AON. I'm sorry. This was an extra slide that I was going to use to complete the network, but I completed here. So let's work on the AO8. So again, we're going to have the start node. And now instead of having a node representing my task, I'm going to have an arc. So we have our first two activities, A and B, are represented by those two arcs. And I'm going to create some nodes just to be able to connect the next task. So these 1, 2 are not representing anything. They're just names that I'm providing to the nodes. So next, let me go to the next slide. So we have A and B. So stage number 2 have the same start. We have 1, we have 2, 1. I'm sorry. This is A and this is B. Let me change the color. So now we go from 1, because C is connected to A, so we're going to have an arc coming from here, and this is going to be activity C. We can create another node. Then we're going to have a couple of activities coming out of the node number 2. These are activities D and E. So this is 4 and 5. And then finally, we have, so we got D and E and C. We're gonna have another node. She's coming from D and C and D. And these are activity F. And then we have G, which is coming from E. And then we have our finish. I'm sorry, so this is 6 and 7. Something that we can do for this network, if you see this node is kind of redundant, you can connect this node, this arc here, and then you're going to have only one arc for F. So can you see that? We are going from D, and then we have 2 arcs for F, but we can eliminate this one if we connect this arc to this node. So let's do that. Then we can also take this out of here. And then just extend those to your finish. And the network will look simple. Okay, so as you can see, the tasks are represented by the arcs. On the AON, the tasks are represented inside the nodes. Any questions? Okay, so now we're gonna look at a larger example, and what we're gonna do is try to identify the critical path for a network. So this is the next example. Now we have extra information. We have the activity, the predecessor, and also the duration. The duration is given in terms of days. So, for example, activity 8 is going to last 5 days. So let's draw the AON network. So let me help you with that. Let's start with the start node. And now in the AON representation, we use the tasks are represented by nodes. So we're going to put the task name, but we're also going to add the duration inside the node. So let me put A, duration of 5, and then we have B with the duration of 4. These are my first two activities. Then we have C, D, and E, which all of them are coming from the same node, node A. So we can create 3 nodes for these 3 activities, and they are all connected to node A. So we have here C3, D4, and E6. Okay, so I'm going to give you some, like 3 minutes to complete the network on your own, based on what we have discussed. And if you have no issues with it, this is going to be part of the exam, so for sure in the exam you're going to have to draw a network. So if you practice now, then you're studying for the exam. Ready? Okay, so let's complete the network. So we have coming from 4, we have, well, let me draw the notes here. We have G5, we have H6, we have F4, J4, and I6. And then we have the finish. So we have A, B, C, D, and E. Now we are looking at F. So F has B and C. Yes.
Switch C and E.
That's okay. So we have G with predecessor D. Then we have H with predecessor D and E. Then we have I coming from F. And we have J coming from these two guys. And then finish. So that's your network. It doesn't matter if you get some overlapping in your arrows, that's okay. Any questions? You're gonna see that network again in a couple of minutes. So now what I want you to understand is how to find the critical path. So we have our network, we have the durations for each task, we have the dependencies between tasks, and now we want to find what is the critical path. What is the set of activities or that path that is going to delay the total duration of your project. So we can add information to the nodes in the network. We can use this notation. And basically what we're going to do, on each box, we're going to add 4 numbers. On this left corner at the top, we have EF, which is the earliest start time. On the other side, we have EF, which is the earliest finish time. In this corner, right here, we have the latest start time. And on the other side, we have LF, latest finish time. And using this notation, we can come up with the total duration of the project, and we can also find the critical path of the project. So this is the same network that we just discussed. We have the task, we have the duration. Now we're going to use the notation that we discussed here to find for each activity these 4 numbers. So let's start with the from left to right. So the earliest time that you can start this activity is 0, and it's going to last 5 days. So that number is going to be 5. Same thing for the next activity, 0 and 4. Then we're going to move to the right. So the earliest time that you can start this activity is going to be the completion time of the previous one. So you're going to start this activity at time 5. It's going to last 4 days. So the earliest finish time is going to be 9. You go to the next one. Again, earliest starting time is 5. So because the earliest finish time of the predecessor is 5. And same thing for the next one, 5 and 8. And you see those numbers are the same because they're coming from the same node, but the actual finish time is going to be different because it's depending on the duration of the task. Any questions so far? Yes?
As far as the textbooks, like the methods,
Yes.
I will not do that.
You can do both. Anyone, that's the one that works better for you. Yeah. I guess you're familiar with this, finding the critical path. Have you seen it
Yeah.
before? Okay. All of you? Yeah. Oh, okay, good. So I don't need to spend that much time then. So let's go to the next slide. So we go and identify the earliest start time. So now it's going to depend, for this case, it's going to be depending on these two paths. So the latest one is going to be this one. So that's going to be your earliest start time. And for this one, that's the same case. You're going to look at both nodes and find the earliest start time. And then you go to the next one, you repeat the process. Then you find that the total duration of the project is going to be 21, which is based on the path that goes through this node. So all activities and all tasks must be completed to finish the project. The shortest path to completion of the network is equal to the longest path throughout the network. So that will be this path, the path that goes from start and goes through this. Okay, now using this information, we can track back the latest time that you can use to start each activity. So we go back using this time, 21, and then we start subtracting the duration of each task. So in this case, it goes from 21 to 17, 21 and 15. 17 is the earliest start time, so you're going to use that as your finish time, so on. And then repeat the process. So based on that, we can identify our critical path. Anyone can tell me from the figure what will be the critical path? So A to E to H to J. Which is here. Okay, so that's your critical path. If you delay any of these activities, you're going to delay the whole project. Okay? Any questions? Okay, so the good thing is that you have seen this before. If you are more familiar or you feel like you can create this path and critical time using a table, that's okay. In the exam, you can do that. And also in the homework. You're going to have some homework based on the material that we discussed today. So you can use either strategy, the one that works better for you. Yes. Any questions? Okay, so that concludes this first lecture on networks and also on scheduling the project. We're going to continue this after our first exam. Our second exam, sorry. So now we have some time to go over the review